Hello and welcome to the Chemistry Made Simple podcast. I'm your host, Matthew Macario, and today this is a short episode to talk about the definition of the standard enthalpy change of atomization. So to do that, first we're going to define it. So the definition is the standard enthalpy change of atomization is the enthalpy change which accompanies the formation of 1 mole of gaseous atoms from the element in its standard state under standard conditions. Okay, what does that mean? Well, firstly, we're dealing with standard conditions. So we're dealing again with pressure of 100 kilopascals and temperature of 298 Kelvin. And the symbol for the enthalpy of atomization is delta H subscript AT. Usually there's a superscript plimsoll liner circle just next to the H as well. We're talking about the formation of 1 mole of gaseous atoms. So the element may already be a gas or it may not. It may be an element that exists, for example, as a diatomic molecule like bromine, chlorine, oxygen. It may be an element that exists as a larger solid structure such as a metal element. In all those cases, we're talking about turning that element in its standard state into 1 mole of gaseous atoms. So turning liquid bromine, which is Br2, into 1 mole of bromine individual atoms in the gaseous state, or turning gaseous oxygen, O2, into 1 mole of gaseous oxygen atoms, individual atoms. Now you might wonder, why would we ever want to do that? And the answer is, well, we wouldn't usually want to do it on its own, but this is a really important standard enthalpy to consider because a lot of the other standard enthalpies that we're going to be talking about talk about starting with gaseous atoms of an element. So this one is going to come up time and again when you construct a Hess cycle, and we're going to be doing an episode on constructing Hess cycles in the near future. So watch out for that. I'll be releasing that soon. Okay, so if you've any questions on what we've talked about today, do come over to our Patreon community at patreon.com/chemistrymadesimple and ask your questions. That's where I'll be answering them. I do look forward to seeing you there. I do look forward to helping you. Thank you for listening to this episode. I hope you found it useful, and if you have had value from it, do consider visiting our Patreon community at patreon.com/chemistrymadesimple, where you'll be able to ask deeper questions about this topic and get more support for your studies too. So I look forward to speaking to you again in the next episode, and until then, do look after yourself and goodbye.